right, guys, another day of calculus. We're still focusing in on limits today. So today we're going to just be learning properties of limits. Yesterday when we talked about limits, they were all limits, I'll call it in simplest form. Limit as x approaches whatever for the function. Okay, today the limits we're going to be looking at are a little bit more interesting than that. Okay, so you'll see what I mean when we get to the examples here in a second. But before we get to those examples, there are 9 important properties of limits that we're going to be able to apply from here on out pretty much every day going forward. Okay, so right now you might be looking at these 9 rules like, what, this looks weird and scary, what is this? Okay, but I guarantee you by next week, all of these properties will be second nature. And they're all pretty intuitive and they're exactly what you hope that you would be able to do with a limit. Okay, so I'm going to go through these one by one. Okay, first up is the constant rule. So I'm going to draw a little graph here for a second. Cool. Okay, so all this is saying is that if your function, this is normally where the f of x would go, right? If your function is a constant, so let's say my function was f of x equals 7. Okay, here it is. They're saying that no matter what x value you approach, let's say I'm approaching 2, I'm always going to be at a y value of 7. If I'm at -4, I'm still going to be at a y value of 7. So if your function is just a constant number, no matter what x value you're approaching, your limit will equal said constant number. Okay, so we'll be using that one a little bit today later on the notes. Okay, next one is the identity rule. So on this one, it says the limit as x approaches c, and my function is x. Okay, hopefully you know that that's our linear parent function. Got a y-intercept of 0 and a slope of 1. Okay, so what's special about my linear parent function is that any point on the function, the x-coordinate and the y-coordinate are going to be the same. So they're saying no matter what x value you're approaching, that y value you'll be at will always be the same. Okay, if x is approaching 2, y is approaching 2. If x is approaching -1, y is approaching -1. Okay, so whenever your function is just x, whatever value I'm approaching will be the same value as the limit. Okay, so these first two are really kind of basic limits. Honestly, we're not so often going to get so lucky that we're having such a simple question like that. Okay, it will come up every now and then, but these next ones are the more important ones. Okay, so coefficient rule. Let's say I have something limit as x approaches whatever value, but it's not just f of x. Let's say it's 3f of x. Okay, well, a lot of times they don't give you the function. It's just a graph. How am I supposed to multiply 3 by a picture on the graph, especially if I don't know the function? Okay, well, all it's saying is that anytime you have a constant, a coefficient being multiplied by your function, you can pull it out to the front. Okay, find your limit, just regular plain old limit, and multiply your answer by whatever that coefficient was. Okay, that's exactly what you would hope that you would be able to do, and it is what you can do. Okay, sum and difference rule. This one's going to come up a lot. Okay, so they're saying if I have a limit and I'm adding 2 functions, the limit of x approaches 3 for f of x plus g of x. Okay, again, how am I supposed to add 2 graphs? What does that even mean? Okay, they're saying you can just take it one at a time. Find the limit for f, find the limit of g, and add them together. Okay, I think this will make a little bit more sense when we get into some examples. So if you're sitting there like, what is she saying? Just bear with me till we get to the examples. Okay, and the other ones are really similar. Just like the sum and difference rule. If you're multiplying 2 functions and you're trying to find the limit of one, find the limit of the other, multiply the answers. Okay, same thing for dividing, unless you're getting 0 for the denominator answer. If you're getting 0 on the top, that's fine. 0, I'm going to write this down actually. 0 divided by any number is 0. Any number divided by 0 does not exist. Okay, really important distinction. You can have 0 on the numerator, but you cannot have 0 on the denominator. All right, this works for powers too and square roots, as we see 7 and 9. If they want you to find the limit as x approaches c for f of x squared, just find the limit as x approaches c for f of x and square that answer, or square root, whatever. Okay, now composition function rule. I think this is, if I had to pick one that was the hardest one, it's this one. And it's not that it's hard, it's just maybe not what you would imagine. Okay, if I'm trying to find the limit as x approaches c for f of g of x, okay, what they're saying is you can find the limit just for that inside function. Okay, the limit as x approaches c for g of x. You'll get some numerical value, okay, limit should equal a number. Then whatever you got for that answer, you'll plug that in for f. And that's just an algebra 1 thing. Let's say, for example, that my limit as x approaches c for g of x was 7. Then here I would just be solving for f of 7. You just plug in and get an answer, hopefully, unless there's a hole or an asymptote or something like that. And we'll do an example like this too. Okay, so like I said, these are our 9 rules that hopefully in a really short amount of time will just feel like it comes natural. Okay, so let's jump into some examples. I'm going to kind of skip around on this notes page, especially today in class. I did not do all of the examples just because I wanted to give a good amount of time at the end of class to work on the assignment. And I've only taught second period so far, but there was a couple people in there who finished the assignment before class ended. Okay, so let's jump right in. Okay, it says use the properties of limits to find each of the following limits. If the limit doesn't exist, state why. Okay, so A, they want us to find the limit as x approaches 3 from the right for f of x plus g of x. Okay, so I know how to find a limit for f of x, and I know how to find a limit for g of x, but I don't really know what this means, f plus g of x. Okay, so what our limit property says that we can do is we can break this up into 2 different limits. Okay, so I'll have the limit as x approaches 3 from the right for f of x. Okay, that'll be the first thing I'm finding. And then I will also find the limit as x approaches 3 from the right for g of x. Once I have those 2 answers, I'll add them together. Okay, so let's go take a look at our graphs. Okay, for f of x here, I'm trying to find the limit as I approach 3 from the right. Okay, so from the right of 3, I'm approaching, and it looks like I'm getting really close to a y value of 6. Okay, so this is going to be 6. Okay, and then same thing for g of x. What am I approaching? 3. So I'm approaching 3, here's 3, but I'm approaching from the right. Okay, so I'm approaching. Looks like I'm getting really close to 8. Okay, so I just want to pause to say something here. If this question would have asked for the general limit as x approaches 3, right here, as I'm approaching 3 from the right and I'm approaching 3 from the left, they do not agree. That general limit as x approaches 3 does not exist. So if that was the case, the second part of my problem would not exist, so the whole answer would not exist. Okay, but in this case, since they specified approaching 3 from the right, that does exist, and I can add the 2 answers together. I get 14. Cool. All right, letter B. Okay, this time we got a little bit more stuff going on. Yes, I'm subtracting these 2 functions, but they've also got coefficients in front. Okay, so I'm going to split it up into 2, one dealing with f and one dealing with g. Okay, so I know that my limit x is approaching 5. Okay, I want to make this as simple as possible. I just want to have a limit and a function together, nothing else really going on. But I can't ignore the fact that that 3 was there. Okay, so I'm going to pull it out in front and multiply that by whatever my limit value is going to be. Okay, and then I'll do the same thing for my g of x. I'm subtracting. I can pull that 2 out to the front, and I'll find my limit as x approaches 5 for g of x. Okay, let's go look at the picture. Okay, I'm approaching 5 here. Here's 5. Okay, so right here, I'm at a point of my graph that is continuous. There's no hole, there's no asymptote. It's just a straight line. Okay, if you're ever dealing with a graph that's just a straight line, your limit will be the same as the function. Okay, so here as x approaches 5 from the left and from the right, it looks like I'm at a y value of 2. Okay, so that's going to be 2, and I can't forget to multiply that 3. Okay, we'll do the same thing for g now. Okay, as g is approaching 5, here's 5. Looks like I've got a continuous part of my graph right there. So it looks like I'm at a y value of 4. All right, and the rest is just basic arithmetic. 3 times 2 is 6, and 2 times 4 is 8. 6 minus 8 is -2. Nice. I find these kind of fun. Okay, I'm going to skip around a little bit here. Letter C is a lot like the one we just did, so I'm going to go to letter D. Okay, so we're doing the limit as x approaches -7 for 3 times f of x over g of x. Okay, again, I want to make my limits look as simple as possible. I can find the limit as x approaches -7 for f and as x approaches -7 for g, and I'm going to use my properties to rewrite this. Okay, so first of all, I've got this 3 in front. I'm going to go ahead and pull that out. Okay, and the 3 is being multiplied with the f. So I'm going to multiply this times the limit as x approaches -7 for f of x. Okay, then I've got that g of x on the denominator. So whatever I get there, I'm going to divide that by the limit as x approaches -7 for g of x. Okay, so let's look at the graphs. Okay, I'm approaching -7. So here on f, here I am at -7. I'm going up. Looks like I'm at a continuous part of my graph. And my y value is +5. Okay, so I'm going to plug in +5 for that f of x limit. Then if I'm looking at g of x, -7 is here. Okay, again, I'm at a continuous part of my graph at x equals -7. The y value is +3. All right, so I'm doing 15 divided by 3 should give me 5. Cool. Okay, let's do one more of these. Let's do f. Okay, so it says the limit as x approaches -3 for f of x squared. Okay, again, how am I supposed to square a picture of a graph? What does that even mean? Okay, what I can do is I can make it simple. Find the limit as x approaches -3 for f of x. And whatever answer I get there, I'm going to take it and I'm going to square it. Okay, so we're just looking at f of x here, and I'm looking where x is approaching -3. Looks like that's a continuous part on my graph with a y value of -6. Okay, so my limit is -6. When I square that, I'm getting +36. Cool. Okay, I've picked out a couple of these questions to be your homework for later. So these 4 will be for you to do in your own time. So let's move right along. Okay, so on this next example, the AP people who make the AP test really like questions like this. You will encounter questions like this on the AP test. Okay, so what they did is all of these limits they want us to solve are in function notation. And at the top, they gave me 3 bits of info. First, they told me the limit of f of x as x approaches c is 3. They also told me the limit of g of x as x approaches c is -2. And third, they told me the limit of h of x as x approaches c is 4. Okay, so we're going to be using all 3 of these pieces of information to substitute into our limit. Okay, so let's start here with A. We got a couple things going on. We're subtracting 2 functions, they've got coefficients, and we're taking a square root. Okay, remember, before we begin, we really want to know how to rewrite this one limit into a couple simpler limits. Okay, so first things first, I know I need the limit as x approaches c for h of x. The limit as x approaches c for h of x. Okay, but in front of that h of x, there was a 3. So I'm going to multiply that by 3. Okay, I know I'm subtracting. And I also need the limit as x approaches c for g of x. Okay, but there was a 2 in front of that. So I'm going to put the 2. There was also a big old square root sign. So everything here needs to be square rooted. Okay, now I've got these two limits that I know the answer to, and I can substitute in their values and just do some arithmetic. Okay, so here, got our big square root sign. We said, they told us number 3 up at the top, the limit for h of x as x approaches c was 4. Okay, minus 2 times. Then they said the limit for g of x as x approaches c was negative 2. All right, so 3 times 4 is 12. Negative 2 times negative 2 is positive 4. When I add that, that's 16. And the square root of 16 is 4. Done. Okay, so just being able to apply those properties of the limits to kind of break it up into something simple, substitute in what they told us, and get an answer. Okay, let's do B. Okay, so for B here, we are multiplying two limits. I want to break it up into some stuff I know. The first thing they told me was the limit as x approaches c for f of x. Okay, and I want to multiply that. They gave me this 5, and I'm going to multiply that by the limit as x approaches c for g of x. Cool. Okay, now I can substitute what they told me. The limit for f of x was 3 times 5. That came with the problem. And the limit for g of x was negative 2. All right, so 5 and negative 2 make negative 10. When I multiply that by 3, negative 30. Nice. Okay, C. Okay, so what's going on with this 7? Is it a constant that's being multiplied? No, I'm subtracting from 7. Okay, this 7, this comes from this first number 1 constant rule. Okay, 7 is the function that I'm being told about here. Now, they didn't tell me anything about the function 7 at the top where they gave me some given parts, but I know that no matter what x value I'm approaching, the limit as x approaches whatever for 7 will be 7. Okay, so that's going to be my first thing. The limit as x approaches c for 7. Okay, and from that, I'm going to subtract the limit as x approaches c for g of x. And that whole thing is going to be squared. Okay, so I know my first limit is going to equal 7. They told me that g of x limit was negative 2. And I want to square that. So this is going to be 9 squared, which is 81. Nice. Let's do one more of these. D. Oh my gosh, lots is going on here on part D. Okay, ain't no thing. We're going to break it up into, it looks like 4 limits that we can plug in, and then we'll do some fun algebra math stuff. Okay, so first on top, I've got this f of x, but it's being multiplied by a 2. So I've got my 2, and then I'll have the limit as x approaches c for f of x. Okay, it looks like I'm adding. Then I've got a 3 times the limit as x approaches c for h of x. Okay, great. Numerator done. Let's do the denominator. Okay, I'm subtracting these two functions. So I'll take the limit of one, the limit of the other, and subtract it. Okay, first up came h of x, the limit as x approaches c for h of x. And I'm subtracting the limit as x approaches c for g of x. Okay, let's substitute in what I know. All right, so I've got 2. They told me the f of x limit was 3 plus 3 times the h of x limit, which was 4, all over my h of x limit, again, which was 4, minus, there we go, minus my g of x limit, which was -2. All right, so I got 6 plus 7 on top and 6 on bottom. So what's that going to be? 13 over 6. Fractions are okay. Cool. All right. These next 3 are going to be yours for homework. Last page here. Okay. These are all about the composition functions. Now, like I said, this is the one that's just a tiny bit different from the others. Okay, here's why. On all these other ones, anytime I saw an F or a G or an H, they all got a limit that went with it. Okay, the composition one is just a little bit different. Only the part on the inside is going to be given a limit. Okay, going back to my property rules at the top. Okay, once I find the limit of that inside function, then I go to this next step. I'm no longer finding a limit. I'm just finding the function's value at that point. Okay, so let's do some examples for that. Here we are, A. Okay, find the limits of the following composition functions. It says, given that f of x equals x cubed minus x squared plus 4x minus 1, and g of x equals -2x, find the limit as x approaches 2 for f of g of x. Okay, so first things first, I want to be able to rewrite this limit into something a little bit simpler, just a limit with a plain old function. Okay, so since f was on the outside, I'm going to go ahead and pull that out. And on the inside, I'll have the limit as x approaches 2 for g of x. Okay, now they didn't give me a graph, but they did give me a function. Okay, so think of it this way. Close your eyes and imagine what g of x equals -2x looks like. Hopefully you can imagine it. It's a straight line, right? -2 slope, y-intercept of 0. That's a continuous function. There's no holes there. There's no asymptotes there. Okay, so just like when we were looking at the other graphs, if you have a continuous function, your limit value should be the same as your function's value there. Okay, if you're not quite understanding what I mean, let me draw a little graph. Okay, and -2x looks something like this, kind of. All right, so if I'm approaching an x value of 2, my function will be down here at -4. Okay, from the left and from the right, I'm approaching that same y value of -4. Okay, so I'm going to rewrite this just one more time. Say the limit as x approaches 2, and instead of writing g of x, I'm going to write -2x. Okay, like I just said, anytime you have a continuous function, no holes, no asymptotes, any just regular polynomial function with no fraction will be a continuous function. Okay, you can take, oh, not what I wanted to do. You can take the x value that we're approaching and just plug it into your function. Okay, so the limit for g of x as x approaches 2 is going to be -4. Okay, so my limit is now gone. I only had to do it limit one time. We're no longer talking about a limit. We're just talking about function notation. They want to know what is f of -4. So I can take -4 and plug it into the function they gave me. So I've got -4 cubed minus -4 squared plus 4 times -4 minus 1. Okay, so I'm going to stop here and talk about something important. If you're taking, I shouldn't say if, when you're taking the AP test next spring, okay, and you're working on the free response question, they have something there called the safe stop. Okay, safe stop means that anytime you are working on a problem and you get to a point where you only have numbers or like adding, subtracting, multiplying, dividing, exponents are okay, you can stop right there. You're done. This is an acceptable answer on a free response question on the AP test. Okay, here's why. On the AP test, they're trying to see if you know how to do calculus. If you've made it to this point, you have done all of the calculus. All you have left is arithmetic. And if you were to keep going and you made like a little dumb mistake, maybe you put -4 squared was -16 by accident, you just lost your whole point. You just got the whole answer wrong, even though you did all of the calculus right. Okay, so if you have a limit, you're not done. You're still doing calculus. If you have function notation, you're not done. You still need to plug something in. Anytime you're working with like PEMDAS kind of stuff, that is a safe stop, okay? Numbers and little like plus minus signs, all that only, okay? So this is a safe stop. You can stop there. Now, if this was a multiple choice question, the answer choice wouldn't look like this. You would have to keep going. Okay, but on a free response question, you could totally stop there. Same is going to apply for my tests. Okay, now quizzes will be multiple choice, so you've got to keep evaluating. But on the test, I'm totally fine on an open-ended question if you guys utilize safe stops. Sounds good. Okay. So we're going to do just a little bit more using a graph this time, okay? More composition functions. We've got the limit as x approaches 3 for f of g of x. F is on the outside, so I'm going to pull that out. And I'm just finding one limit as x approaches 3 for g of x. All right, so let's go look at the graph of g. Here it is. I'm approaching 3. Here's 3. Oh, I'm at a continuous point in my graph. Looks like my y value is 1. F of 1. Okay, now I just want to know, what is my function value for f at 1? Looks like it's -2. Okay, if this problem would have asked me for the limit as x approaches 1 for g of x, I'm approaching 2 different spots there. The limit at 1 does not exist. So the entire answer to the entire problem would not exist. That's going to help you out with part C on the homework. Okay. Last one we're going to do. They want the limit as x approaches -1 for g of f of x. Okay, now g is on the outside. So I'm going to pull g out. And I'll find the limit as x approaches -1 for f of x. Okay, so I'll go look at f of x. I'm looking at -1. Here I am. It kind of looks like there's a hole there, but the graph just got cut off because that's where the 6 is. It's not a hole. Okay, my y value there is 6. G of 6. Oh, I'm sorry, it's -6. Oops. There we go. Okay, so over here, rats, I can't see -6. Does that mean it doesn't exist? No, you wish. Okay, this line has an arrow. It can keep on going. It looks like I have a slope here of -2. So if at -4, I was at -3, that means I'm going to go down 2 more. At -5, I'd be at -5. And then I'm going to go down 2 more to -7. Cool. All right, and the last 2 are yours for homework. So it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 homework problems. That's not too bad. Okay. Tomorrow we'll work with limits just a little bit more. And remember that Friday is our quiz. Okay. The quiz, I'm currently writing it up right now. I have all my questions picked out. There won't be a ton of this stuff or a ton of the stuff that we're learning tomorrow on the quiz. It's mainly going to be stuff from yesterday. Okay, so you won't really have to manipulate the limits too much. It'll be looking at a graph, looking at a table, explaining the meaning. Okay, it's more just about the basic foundations of limits. Our quiz next Friday will have a little bit more of this stuff. So we'll have more time to practice it before we're quizzed over it. Okay, so as always, if you guys have any questions or anything like that, you know how to reach me, email, in class, remind, whatever, all that good stuff. Okay, hope you guys are having a great day, and I'll see you tomorrow with another video.